All right, so today we have a little intro to functions and y-intercepts, okay? And the reason that we're doing this is the next big thing we're getting into are linear functions. But before we can get there, we got to know some information about functions and x and y intercepts. And then tomorrow's going to be all about slope, all right? So that's where we're at, that's where we're going. So let's go ahead and look at this. So the first thing is functions / linear functions. And the first thing you want to know is how can you tell whether a function is linear or not? And then these next things that we're about to fill in are the ways that you can tell that. The first way, if they give you a graph, okay? To be a function, it must pass the VLT, which stands for the vertical line test. VLT stands for the vertical line test. All right. Now, the cool thing about that, all right, with it, the vertical line test, is it's really as simple as taking your finger, taking a straight edge, taking your pencil, whatever it is, if they give you a graph, and just running it across. If it ever touches the graph, whatever you're looking at, if it ever touches 2 points at the same time, it is not a function, okay? That's a little backwards from things, how some people like to think about it. But if it ever touches something at least twice, it is not a function. You only want it to touch 1 point at a time. So as you move it across, it should never be on 2 points at once, all right? That is the vertical line test. All right, now the next one, you could be given a table of values, points, or a mapping statement. Okay, and if there is, the way to tell whether it's a function or not, there can be no repeats in the x value. Okay, so that means you will never have the same number show up as your x values. All right, now this next piece is the part that you probably haven't necessarily heard before, and it is about linear functions. And it says, how can you tell whether a function is a linear function? All right, well, if you are given a graph, when you look at it to tell if something is a linear function or not, it should look like a line. All right, how you would have known that? The word linear means line. All right, so first it's got to be a function. Then if it is a function, if you're given a graph, it should look like a line. Now, the next one, you could be given table of values, points, or mapping. Here is how you decide when you are looking at that thing. All right, if you are given those, it must have a constant rate of change. In other words, the slope is the same all along the graph. Okay? Those are the big things there. So if you were given the table of values, points, or mapping, you would have to have a constant rate of change, meaning the slope has to be the same. Now, the next one, if you are given an equation, all right, here's how you can tell if something is linear. All right, and these are actually, they're the big key steps that you need to know. All right, if you were given the equation, the variables have an exponent of 1. That means you will not see like an x squared or a y squared or a y to the third, x to the third. It's got to be just a y and an x. All right, no variables can be multiplied together. Okay, now actually, so let me do this. I'm going to come out here and write some examples of what we don't want. So like you couldn't have on the first one an x squared or a y to the third. Those are bad. Okay, so that's what you don't want. Okay, then if things were being multiplied, that means you can't have two variables next to each other. Or you couldn't have two variables with the multiplication between them. That is bad. All right. Now, the last thing that can't happen is there can be no variables in a denominator. Okay? What is the denominator? The bottom of a fraction. So an example of that is you couldn't have 3 divided by x. Or you couldn't have 17 over 2y. Those are things that are bad because the variable is in the bottom. Okay? Now, the last little note to make, and it's just a note that we have, it's just something that we need to know, is that all linear functions can be written in the form ax plus by equals c, where a and b are numbers that are not 0. Okay? Just something to know. As we get more into linear equations, that point's going to come up, and that's something that we're going to talk about. All right? Now, the last thing that we're going to look at today and talk about are your x and y intercepts. Okay? X and y intercepts. Now, x and y intercepts are kind of cool things, and we're going to talk about what they actually are. In x-intercepts are where the graph crosses the x-axis. Now, I'm going to draw out to the side what the x-axis looks like. Remember, the x-axis is the horizontal line. Okay, it's the horizontal line where it goes through 0, 0. The y-intercepts are where the graph crosses the y-axis. And the thing to remember about the y-axis is it goes up and down. Okay? All right. Now, here's what you've got to do. To find the x-intercept when you are given an equation, you want to plug in 0 for y. And when you want to find the y-intercept for a given equation, you plug in 0 for x. Okay? Now, here's the easy way to think about that. If you want the x-intercept, all right, that means your y can't have a value, all right? And think about why that makes sense. If you were trying to plot a point and you were given an x number, which way would you move on the graph? Left or right? But then if it's 0, you're not going to have to go up and down, so you would stay on that line, which is your x-axis. When it's the y, you don't want to go left and right. So you need your x to be 0, but then your y can go up or down, whether it's positive or negative. Okay? All right, so here's the example down at the bottom. They want you to find the x-intercept on the first one. Well, that means that you need to plug in 0 for 0 for y. And that's going to go where that parentheses is. I just kind of helped you out by putting a parentheses there. All right, now, the cool thing about it is when you plug in 0, what is 0 times anything? 0. So that just goes away. So you're really left with, and I'm going to draw it up here just so I have some room. You're left with 3x is equal to 9. Well, what do you do next to get x by itself? Divide it by 3, and you end up getting x is equal to 3. So that means your x-intercept equals 3. Now, notice how I abbreviated intercept. Not a big deal, but I just don't want you to be confused. Now, same idea, but when you're finding the y-intercept, you want to plug in a 0 for x. But just like we just talked about, 0 times anything just goes away. So that means that now you got 4y is equal to 9. You would need to divide both sides by 4. And you would get y is equal to 9 over 4. Okay? If you wanted to as a decimal, that is 2.25. So here you would just say your y-intercept is 9 over 4 or 2.25. Anybody got any questions? Okay. That's the big stuff from today. All right. Where we will go tomorrow is we're going to start looking at slope and how to calculate slope. What I'm going to do to you now is pass out to you your little homework page, practice page, and that's what we're going to do the rest of class. Nothing's got to be uploaded today. If you did not get me the worksheets from yesterday, get them to me by midnight tonight, either on Canvas or you can turn it into me a physical copy today if you want to take advantage of that. Ready, set, go.